Hi guys, in this video we are going to discuss how to implement parallel version of Quicksort algorithm. Now let's start our discussion by looking at the steps of Quicksort algorithm first and then move on to the parallel version of implementation. Now in the Quicksort algorithm, given a list, we first pick an element called pivot element, which is just random element in the list. And then we reorder the list using pivot value in a way that all the values lower than the pivot will be put in the left side to the pivot and values higher than the pivot will be put into right side to the pivot element in the list. And then we recursively call same function for that lower part and the higher part of the list as shown in the below diagram. So after reordering, values less than the pivot will be in the left side as shown in the green color boxes, and the value higher than the pivot will be in the right side of the list as shown by these blue color boxes. So after this reordering, we will make recursive call to parallel quicksort with each of these parts. Now let's see an example. So here we have list of integers. So in this case, I will select the first element as the pivot value. The value would be 8. And then we have to reorder the original list in a way all the elements less than 8 will come left side to the 8 in the list, and all the elements higher than the 8 will come right side to the 8. So after reordering step, this will be our outcome. And we can mark each of these parts as the lower part and the upper part. So after this reordering step, we can make recursive call to the Quicksort algorithm with each of these parts. So if we call Quicksort algorithm with this lower part, in that case 3 will be selected as the pivot value for that list, and then it will reorder that list. So the final outcome for the recursive call will be like this. And for the upper part, the final outcome for the recursive call will be like this. Now one thing to notice after this reordering step, that there is no relative ordering between the elements in each of these parts. So as you can see, value 9 and the 11 appears after the value 12. So there's no relative ordering in the elements in each of these parts. But that's what we are going to achieve by another recursive call with each of these parts. So let's discuss how to achieve these steps with the implementation details. So in our implementation, we first move the first element to the list called result and make that element pivot element. Now keep in mind that in our implementation, after this first step, our original list contains one less element, as you can see in this second figure. Now after selection of this pivot value, then we reorder this original list in a way that the lower part contains all the values less than 8 and the higher part contains all the value higher than the pivot element. And then we made recursive call to the Quicksort with each of these parts. Now as you can see in this diagram, this recursive call will goes until it sorted out that particular part. Now after this recursive call return for the lower part, and then after this recursive call return, the result of the recursive call with the lower part of the list will be put left to the pivot element in the result list. And the result of the recursive call with the upper part will be append right to the pivot element in the result list. Now after this step, we have the sorted list. Now let's see the implementation for the sequential Quicksort algorithm itself. So in this implementation, first we check the recursive function return condition. So if there's only 1 or 0 element in our list, there's no need of progress, so we can return immediately. Then we have select the pivot value as discussed before. So here we have first move the first element to the list called result list using splice function and made that first element as the pivot element. Now after selecting pivot value, we are going to reorder our remaining list using std partition function. Now condition for this partition process has provided as the lambda expression. So this partition function will reorder the list in a way that all the elements which satisfy this condition will be left side in the list and all other elements will be in the right side in the list, And also this function will return the pointer to the boundary of those parts. And then we are going to move the lower part of that partitioned list to the lower list. So after this step, our lower list has the lower part of the partition list, and the original list will now only contain the upper part of that partitioned list. Now afterwards, we can call Quicksort recursively for each of these lists, and result of these two recursive calls will be stored in the two new lists called new lower and new upper, so that we can prepend the lower part to the current result list and append the upper part to the result list as well, as we did in these two statements. Here we have our sequential implementation of Quicksort. Now the conversion of the sequential Quicksort to parallel Quicksort is quite easy. Now let's see the parallel version of the Quicksort. Now in this parallel version, the main difference here is that instead of calling Quicksort for the both upper and lower part in the current thread, we have used async tasks to call Quicksort recursively with the upper part. So as you can see here, we have called Quicksort for the upper part in the asynchronous task. And also we have acquired the future associated with that asynchronous task in the construction, so that we can call that future.get when we need the results, as we did in this statement. So now you can see how easy to implement the parallel version of Quicksort if we had the proper sequential version. So that's it for this video. I hope you understand the concept of parallel Quicksort. Thank you.